Welcome everyone to today's edition of Willow's Weather Briefing. Today is Saturday, May 24th, 2025. Today's hazards, we are expecting excessive rainfall throughout portions of the central to southern plains to the middle to lower Mississippi River Valley. And also, we have a slight risk of severe thunderstorms across portions of the central to southern plains, stretching towards the lower Mississippi valleys and portions of the southeast. We also have an elevated fire weather risk across the Four Corners region down toward the Mexico border. And also unseasonable heat continues in southern Texas and the Florida Peninsula, especially in urban areas in the Florida Peninsula where you won't get that much nighttime relief. Above average temperatures for much of the Northwest and Deep South, below average temperatures for much of the central United States, Midwest, and Northeast. So here's our satellite look right now. We have a bunch of complexes here making its way through the central to southern plains into the Ozarks region. We also have this jet impinging into the western United States, which will cause some disturbed weather later on. And in general, elsewhere, pretty quiet, especially in areas such as the Northwest. Quiet and pretty mild outside, and in the Northeast, quiet but pretty chilly. Here we go. Here's our drought monitor. The solid lines demarcate major concerns of drought. So please pause the video if you want to learn about that. Here is our current watches and warnings. Pretty busy with those convective complexes here in the central United States, but first let's go through the others. Here's a frost advisory for much of the northern tier and upper Midwest, upper Great Lakes region, associated with that cooler temperatures with the constant troughing we've been seeing and the upper low level systems we've been seeing up here. Red flag warning here in western Colorado. And over here, the warnings associated with our complexes, we have a big stratiform region dumping a bunch of rain in areas such as southwestern Missouri and northern Arkansas. And the convective regime of this complex, of course, is associated with some severe thunderstorm watches and severe thunderstorm warnings here in eastern Oklahoma. Here's our surface chart and evolution. We have a meager low-level response causing some warm air advection and some thunderstorms around these areas. We do have an enhanced flash flooding risk over here around the Boston Mountains region and the Ozarks. Broad severe thunderstorm risk across this baroclinic zone or frontal regime. Moving on tomorrow, we still have this high pressure system in the north kind of aiding in bringing some cold air down, keeping that battlefield of warm and cold air along this severe weather risk region. The severe weather risk stretches from northern Texas all the way to northern Alabama tomorrow. We also have a continuation and maximization of the flash flooding risk here centered around the Boston Mountains and Ozarks. And on day 3, Monday, we still have that battle between warm and cold air. The battlefield is still continuing here. Continuation of that flash flooding risk in pretty much the same regions, all the way from Arklatex to the Mid-South, and a severe weather risk associated with that as well in northern Texas. Here is our excessive rainfall forecast. Today, a slight risk centered over the Boston Mountains. Day 2, we actually have a moderate risk of excessive rainfall. This includes areas like Joplin, Tulsa, and Bentonville, Fayetteville, Arkansas. So this is our biggest concern today. Tomorrow, today we're progged to have around 3 to 5 inches in the slight risk region, but tomorrow we're expected an additional at least 2 inches in these areas, which will push flash flood guidances up in the upper echelon. So we'll see possible flash flooding, likely flash flooding in these areas. In day 3, that frontal regime will shunt a little bit south, bringing the battlefield down here a little bit from the Arklatex region up to the mid-south. And finally, that frontal regime will continue to shunt southward as we get the lack of low-level responses here in the Rockies, and that will just cause a broad marginal risk for day 4, and also day 5 marginal risk associated with some convection over here and the lingering frontal regime and moisture. Here's our fire weather outlook. Day 1, elevated fire weather risk over the Four Corners region, Great Basin, down towards the Mexico border. Sort of the same areas. Elevated fire risk for basically shunted down from today down towards the Mexico border in areas like southern New Mexico and far western Texas, such as El Paso. No extended range fire weather risk is expected. So here is our severe thunderstorm outlook. At day 1, slight risk over areas such as western Texas all the way towards the southeast, primarily for tornado, wind, and especially hail. Significant hail progged, especially in areas such as Oklahoma City. We have Lubbock, Texas, and also cities like Elk City, Weatherford, Oklahoma. So have a 5% tornado risk in similar areas: Oklahoma City, Tulsa, Edmond, Oklahoma, going into the Wichita Falls area. Also, Lawton, Oklahoma is also in this 5% tornado risk. I wouldn't rule out a significant tornado in this risk, but the SPC demarcated a 5% with a not so great confidence in the spatial coverage of these storms. Day 2 outlook: slight risk for primarily the same areas. 2% tornado risk in, again, very similar area to today's 5% risk. But the primary concern is going to be wind and large hail. And on Monday, we have a slight risk of severe thunderstorms located in northern Texas. Hazards at this point look to be primarily strong wind and hail. No extended range severe weather outlook at this time. So here is the National Weather Service heat risk. Heat continues in southern Texas and the Florida Peninsula, especially in the urban areas here due to that urban heat island effect. That will continue into tomorrow or early next week, but we will see a depletion of the heat by midweek next week thanks to that front finally shunting off some of the warm air down to the south. And by late next week, we should see a return to close to average temperatures for much of the southern United States, except possibly far southern Texas and the urban areas of Florida. But we will see a heat risk start to increase in the west associated with some ridging, especially areas such as the central valleys of California could reach temperatures very, very high, up to 100 plus degrees, especially in the north areas of the valley, up to 105 degrees right now, late next week. So watch out for very hot weather in the Central Valley of California starting late next week. But right now, our focus is the heat in this area, as they've been consistently above average for the past week or so at this point. Here's our extended range hazards outlook. Of course, the severe weather in northern Texas, northern central Texas, later on next week, and a broad flash flooding risk across these regions right here, and the excessive heat risk for far southern Texas and the Central Valley of California. Here's our 6 to 10 day temperature outlook: above average for much of the western United States and below average for the centered around the mid-south, but for much of the eastern United States, also above average for the Florida Peninsula. Here's our 6 to 10 day precipitation outlook: below average for much of the northern United States and above average for much of the southern United States. So let's look at our storm threat for today. Zoom in on this region. This is what we call an ensemble of solutions. These are not just one model. Each color represents one model. But generally, how I interpret this is that the more paintballs we have with different colors, the more confidence we have in the spatial coverage of storms in that area. So let's move on to right now. Right now, it is about 1:30Z. Let's move on to around 2Z. Big spatial coverage around these regions, which is well progged by most models. But as we move forward, that will shunt off down to the southeast. We'll see atmospheric recovery with eastern extent, but also untapped potential for these areas in here. Move actually to the southern plains here so that we get a better sector. And as you can see, storms sort of initiate off that stationary front and dry line around, let's just say, 4 o'clock p.m., and they will migrate off to the east. Some models prog upscale growth fairly quickly, but some models have a sustenance of that convection, especially off the dry line here in Texas. But still, some storms have storms firing off here in Oklahoma. But the most confidence we have in initiation is off the dry line in areas like Lubbock, Texas, moving off to the east towards areas like Wichita Falls. So upscale growth, kind of a question mark, but at least initially we should see an all hazards threat. If storms can remain discrete over towards the night, then perhaps we'll see an enhancement of the tornado threat as well. But let's go ahead and look at our actual models. Here's our 500 millibar height. We have a general troughing pattern over here in areas such as California, bringing some enhanced flow into the Rockies, causing those transient surface responses that allow some of our warm air to transport north after we have a high pressure dominating over here in the Midwestern regions. So as we move on, as we move forward, this trough will slowly deplete, causing a lack of surface responses in the Rockies, which will cause our cold front to move southward. So let's go ahead and look at our surface responses. Here's our precipitation type. Right now you can see kind of the battle over here. We have a high pressure across the northern Midwest towards the Canadian Shield. We have a low pressure response over here in the southwestern United States along the southern Rockies and the Sandia Mountains. So we have those convective responses today. Same thing tomorrow, especially along that stationary front, and same thing on Monday along that stationary front as those low pressure systems continue to transport Gulf air to the north while the high pressure system attempts to shunt cold air south. And we can kind of see how this affects our moisture return. We can see the moisture just the 70s dew points try to transport north, but is blocked by that high pressure and stationary front in the central United States, and that sort of continues off until later. Finally, the moisture just kind of stays in the southern regions of the United States. Temperature anomalies, we see this broad pattern of much below average temperatures in the eastern United States and above average temperatures in the western United States, at least until late next week, where we could see a shift in the pattern a little bit, bringing some above average temperatures or at least near average temperatures to areas that have seen below average temperatures for the past week. Finally, what I want to look at is our upper air pattern in the future, way off into the future, like late next week. We have a semblance of an upper low, which would continue to bring below average temperatures up in these regions, but a large upper level ridge building in the western United States, which will cause above average temperatures for much of that region, and that ridge will slowly make its way east, bringing our above average or at least near normal temperatures to regions that have seen that much below average temperatures this past week. So let's go ahead and move on to today. Focus our let's focus our analysis here to these areas. Let's just start with a broad view of reflectivity. So we can see this low pressure response over here beginning. Let's actually move onto the recent model run. Low pressure systems kind of centered over the Texas Panhandle, Oklahoma Panhandle regions. And this will slowly churn up moisture, increase your baroclinicity, your means of forcing over here in areas such as Oklahoma and Texas. HRRR actually shows pretty neat supercells over here in northern Oklahoma transferring down towards the south. You can even see the little bean shapes that they take on the stationary front. The dry line, the HRRR doesn't really convect much on the dry line, but we saw with the HRF runs that a lot of the convective allowing models did. So I sort of question the solution a little bit, but this solution is definitely more robust here in northern Oklahoma. Take a look at our dew points. Our dew points here, they start to transfer north, at least the 70s more robust dew points start to transfer north, shunted by that stationary front a little bit by 20Z or 3 p.m. So this is probably one of the reasons why the HRRR is initiating, because of that moisture return. Moisture helps lower your level of free convection and helps with initiation. So perhaps that is why we are initiating up here. Perhaps the reason why we're not initiating down in Texas is because the dryline convergence really isn't that powerful. So we're probably struggling to convect over there. But there is a lot of convergence in northern Oklahoma, so it isn't really a surprise why this model is convecting in that region. Go ahead and take a look at mixed layer CAPE. This is our instability in the atmosphere, and large amounts of mixed layer CAPE along that boundary region up to, I don't know, is that 5,000 joules per kilogram up here in Oklahoma. So plenty of juice per se in central Oklahoma for these storms. But let's not forget that the dry line will probably initiate down here, so we'll probably see initiation south of the Red River Valley into these just as strong CAPE values. Let's look at our lower level CAPE, which is important for something like tornadoes. As you can see, 3 CAPE around Oklahoma. This is probably another reason why we are initiating. I'm kind of worried about over-initiating along that boundary because of just how nature of the boundary. It's pretty strong forcing, and also the amount of low-level instability. It's going to be easier for parcels to reach that level of free convection and convect freely, so possibly over-convection an issue there. But we still have to take a look at something like shear vectors. So pretty high low-level instability. Perhaps if storms do end up initiating in northern Oklahoma and maintain discrete, this is kind of where your tornado threat is going to be maximized, around northern Oklahoma, Oklahoma City, Edmond, Oklahoma. Maybe perhaps storms will initiate south of Enid, Oklahoma. Let's look at our bulk shear values, 0 to 6 kilometer. Because of the meager flow, we have a lot not too impressive of bulk shear values, but we still see bulk shear values around these regions at pretty high levels. Let's actually take a zoom in a little bit over here in Oklahoma. So we see convective initiation around these regions. Your bulk shear vector, your stationary front, remember, is east to west, so your bulk shear vectors aren't really that perpendicular to the boundary, and given the high low-level instability, high amount of moisture, possibly lower LFCs, I do have concerns of a bit over convection in this area. Convection is definitely progged to be much more discrete along the dry line, but that comes at the expense of possibly having less bulk shear to really organize storms in that area pretty quickly. Let's look at low-level storm relative helicity. This parameter is very important for something like tornadoes. Not too much to work with, possibly sub-storm relative helicity along the secondary boundary along here, and that storms may be able to produce and maintain low-level mesocyclones pretty early on, but our main tornado risk won't really come to fruition until later on into the night. Even then, it doesn't really seem like we have that strong of a low-level jet response, at least with southern extent. Possibly with northern extent, we do have some semblance of a low-level jet response, possibly because of how weak and transient this low-level cyclone is. One of the things that we look for with a strong low-level jet response, at least in terms of the low-level cyclone theory, the isobaric theory, is that we have a strong low-level cyclone, which will bring isobaric wind, or rather an isobaric wind response, and increase your low-level jet in the eastern portions or the southerly portions of your low-level cyclone. So that's my theory to why we don't really have that much of a low-level jet response. This is probably mostly diurnally related, but nonetheless, still sufficient storm relative helicity for a hazard like tornadoes. I do think it is fairly conditional, and the spatial coverage of tornadoes is sort of at question, but I think if storms remain discrete, we have a decent low-level jet response, you could have potential for a strong tornado, but that's a lot to ask for, so that's why SPC maintains a 5% in this area. So let's go ahead and take some soundings. I'm very curious to see what the environment here is in central Oklahoma. Go back one here. So as you can see, the low-level lapse rates aren't that impressive, but I do believe that your LFC will be pretty close to your LCL here. And if that happens, if you have the stationary front and your shear vectors are not that conducive, then perhaps we'll see training thunderstorms in a more clustered storm mode rather than a more discrete one. We saw how the shear vectors were oriented pretty close to the boundary, and because of the amount of forcing we'll have and the low LFCs, then I don't have enough confidence to really say that we'll have a discrete storm mode. But look at this environment. I mean, this environment's pretty darn good. I mean, 3 Cape, 100 joules per kilogram, well sufficient for significant tornadoes. And also look at that shear, big shear values, 150 surface to 1 kilometer SRH, which is good for tornadoes. I mean, this is, besides probably the messiness of the storms you'll probably have with this much storm relative inflow and not that much storm relative outflow, these upper levels are much to be desired. I mean, this is a pretty classic high precipitation type tornado sounding. So again, fairly concerning look, but I do have questions regarding stuff like storm mode and the longevity of these storms with regards to your low-level instability and also your clustering up. And you have to share the energy, rather, if storms if updrafts cluster up a little bit. So let's take a sounding just ahead of the dry line in Texas as well. Get pretty wonky. I'm gonna do a sin. All right, don't do this unless you really know how to interpret things. I'm gonna go to mixed layer cape and try to get our axis of instability here just ahead of the dry line. As you can see here, I mean, pretty warm temperatures, but our photographs are looking a bit wonky. They are outside the influence of that boundary, and a lot of convective inhibition, especially at the low levels. This is not really a good look when you're looking at initiation for thunderstorms. Our convective temperature is all the way up at 103 degrees Fahrenheit, which, I mean, according to this model, there's a reason why it's not initiating along the boundary, right? It's because you have no good low-level lapse rates. Oh, well, you have good low-level lapse rates, but no low-level instability. Your convective temperature is all the way up to 103 degrees Fahrenheit, a lot of surface-based SID. So you probably won't get anything initiating off the dry line, off of the dry line. A dry line is one of the most meager forcings we can get, so that's probably why they're not convecting. Go ahead and take a look at a model like the NAM. You have to go back to 6Z for this one. But we have this sort of a stationary front moving southward, possibly outflow induced by this initial storm mode. But as you can see, boundary is much further south on the NAM compared to the HRRR. Take a look at how this resolves the convection. Not much convection off the front at all. Very interesting. But we have some semblance of convection off the dry line here. So nonetheless, let's take a look at the environment that the NAM has. Let's just see what's going on here. Let's take one where that storm initiates. Take one further. Right here. As you can see, an interesting capping inversion progged by the NAM that just wasn't entirely there by the HRRR, but a lot of cape. I do believe this is a fairly realistic thermodynamic profile. That inversion kind of eats up your low-level cape a little bit, but still should be sufficient to initiate storms. I am a bit puzzled to why it doesn't. And very good storm relative velocity over 200. In fact, this is better, at least closer to the boundary where you might get enhanced wind fields that might be more conducive to storm relative velocity near the boundary. Nonetheless, the NAM better kinematically wise, which is not that surprising, but definitely could initiate on the dry line with a sounding like this. I'm not really understanding why it isn't sustaining, but definitely a complex setup we have coming up here. The positioning of this boundary that we see over here, I'm actually curious to see what kind of boundary we have here. It looks like an outflow boundary of some sorts, not really much of a wind shift. It looks kind of like an outflow boundary by the convection that we had this morning. It depends how far this translates south, how much convergence we'll get along this outflow boundary or stationary front, and if we'll also get any convection along the dry line, especially with northern extent, maybe can tap into that enhanced storm relative helicity near this outflow boundary. So pretty complex forecast coming up. If any storms do form, especially in areas, I think what I'm pinpointing here is highest confidence of areas with severe weather is possibly in areas such as central Oklahoma towards the Red River Valley, possibly towards northern Texas region, like this region right here. That's sort of the regions of concern for today. But in terms of significant hazards, hail is definitely up there. Very good hail soundings, no matter how you put it. But in terms of tornadoes, I do think this is a day to put a 5 hatched. I know the SPC is working on implementing that into operations, but if there was a day to put it in, I think I would put it in today. I mean, things have to really go right for a significant tornado to really produce, but I do believe that at least with some of the solutions we've seen with the HRRR and also the HREF, there is a chance that we get a discrete supercell, or at least semi-discrete supercell off the stationary front, could tap into that enhanced storm relative helicity and spin up a strong tornado in pretty populated areas around central Oklahoma. So that is just my opinion, though. Take everything what I say as my opinion, but that is what I see with the models. So that is going to be it for today. If you enjoyed the briefing and my analysis, please leave a like and subscribe if you want to hear more from me. And of course, if you want any specific information regarding your area, please refer to your local broadcast or National Weather Service meteorologists. Thank you and have a great day.